Okay, hello. Good afternoon. I've been trying to record this session for a while now. It's just my internet connection on this phone, through this phone. It's really very flaky and it's just getting too difficult. So let's get started here. Let me share the screen. No, this is not for you to see. What should I say? Yeah. All right. So the agenda for today is some sort of demonstration of interfaces. I couldn't cover that in our yesterday's session for enumeration. It took quite a while. Like it was, I think, a 1 hour video recording talking about that. So I couldn't cover interfaces there. Um, we are going to do this today. So we'll talk about interfaces through some concrete examples. Let me create this project, a Maven project as usual, and let me give it a name. So it's going to be a demonstration of interfaces from Southeast University. And let us go and finish this. Okay, so we'll have our Maven project ready, and we'll have to tweak a few things to get it up and running. But you guys know that already. Like we'd have to tweak the settings to say that the module will use a higher version of Java, not just JDK 1.5. And that we find under build compiler. No, not here. I thought we did. Java compiler, yeah. So we don't have a module for this. Why is that? Let me see. Oh, we don't even have any code and no base code here. So let me start this. Let me start a package called interface demo. And within that package, let me create a class, a main class. And just like yesterday's session, we will have a constructor. So we'll have public main as a constructor, which does nothing but says, this is too slow. It says hello, right? And from public static void main, we'll just call this constructor, and this gets it up and running. So we call the constructor, we instantiate this, an object of this class. And probably it looks a little bit odd for you. And now it probably makes more sense. But it's not going to get used anyways, this name of the object. That's why I ignored that. Now, if you run this project, it will print out hello. Okay, so what we see right here is that it says release version 5 not supported, and which is fine. There are two things that we needed to change beforehand. Yeah, now it appears because now we have some code and it looks at the package. So we can choose the target bytecode. I got JDK 14 installed here. I could go with Java 9 or anything as such, but I'm going with JDK 14 just because I have it already, right? Why not? And for project structure, this is where we gotta make sure that we have the advanced stuff. And yes, this one. So now it should run. So nothing really new in here till this point. We've been through this before, so we know all about that. Now, what I would like to start with, it's also an example that we have covered before, but let me create a separate package to separate out these different examples that we're going to go through today. This is going to be about some bank account example that we have used so many times. Now, let me bring this up. So for a bank account, what we covered in our class when we talked about inheritance is that all bank accounts, they will have some account number or bank account ID. They will have a name, and they will have a balance. There can be a lot more other things, but we can ignore them for now. What is important to understand is that we will have some getter methods, we will have the constructor and all that, which I'm skipping for now. What we will also have is that we will have a deposit method that allows us to add money to this account. And this is where we will pass the amount which is of double type, right? So that's that. And we'll also have withdraw as another method. Okay. So this is the basic structure of a bank account data type. Okay. Now, from this bank account data type, what we saw is that the basic structure remains the same for all bank accounts, but the implementation varies when you deposit, when you withdraw, or there could be other calculations based on it. There can be other implications of it. So what happens is that we can have subclasses, like we can have savings account. We can have credit card, or we can have current account, right? So when we create these subclasses, we will add the extra attributes we need, we will add the extra methods we need, but it's going to inherit everything from the bank account. So savings account will do that, and then current account will do that. And however many bank account types we have, they will all do that. So what I want you guys to understand is that if you look at it, the actual idea of deposit and withdraw, we can implement that within this bank account type, but we can also say that this is just a contract. This is just saying that, yes, we have to have the deposit and withdraw method. We don't know exactly how it's going to work. The subclasses, they will define exactly how this is going to work for a savings account or for current account, right? So we don't know this at this point, but we will leave it on the subclasses to define this. So in that sense, what we will essentially say that the idea of deposit and withdraw, it's very much abstract. Okay, we don't know how deposit works, we don't know how withdraw works, but savings account knows that, current account knows that. So when we get to this point, this idea is concrete, this idea is solidified. So we know how to implement them here in savings account, we know how to implement them here in current account. But when we talk about the idea of deposit and withdraw, at this point, this is not really clear, right? So one thing what we could do is we can We can create a class called bank account, and we can create subclasses called savings account and current account. When we do that, we will have to give body for deposit and withdraw. That's the way to go. So let me draft a very quick code for this. So we'll have this bank account class, and it has private int ID, private string name, private double balance. And along with that, we will bring in the constructor, right? We will bring in the getters. And let us also have a toString method. So somehow I got extra spaces here. So let's have the toString. So all these things, they are getting written by the IDE. I'm not doing anything here yet, but this is where we will start writing. So public void deposit double amount. This is where I want to write the code. Okay, and I really do need to write the code because I can't just leave it blank. And this is a good example where probably I would leave it blank because I don't know how the deposit method or how the withdraw method works. We don't know that. Actually, we do, but just for the sake of example, I'm just saying we will have to do this, that we will have to give a body just because it wouldn't allow for any normal class to leave it blank like that, right? So yeah, having classes doesn't really solve this problem. We will create subclasses, of course. Let me create a dummy subclass where we are going to define this. So we'll call this savings account. Okay. And we will say extends bank account. So everything that we have in bank account, we will inherit that here. Create constructor matching superclass. Yeah, sure. But what I also want to do is I want to override some of the methods. So override methods, which methods I want to override? These two methods. Yeah. So now here I can write exactly what we're going to do with these things. Now, what you'd also understand, and we have covered this before, having this balance set to be private doesn't really help because I need access to this. And if you mark it as private, it just wouldn't work. Let's say that the logic that we want to implement here is that it's much like Bcash. We have the amount in our bank account or Bcash account, but when we are trying to send money to someone or when we are trying to withdraw money out of our account, Bcash takes something away. Okay, so for now we'll just say that every time you withdraw money, keeping in touch with Bcash's send money feature, we will just deduct 5 taka from there. Okay, so what we will do is we will say balance is equal to balance minus amount minus 5. Now, obviously, you'll need to add some checks to see whether I have the amount within my bank account. I'm not doing that right now, and I want to simplify the code. So this one doesn't work because balance has private access. In order to give access to a savings account, we will make it protected. And that way, this is not going to complain anymore. So for deposit, let's try to walk the other way around. Every time you deposit, I will give you some incentive. I'll give you some bonus. So every time you add money, it's going to be balance plus amount plus, let's say, 1 taka extra. So this thing doesn't work because we haven't provided any body here. One thing we could do is for deposit, we can say that the default behavior is balance equal to balance plus amount. And no one's complaining now, so this is one way to do it, right? However, if we want to stay put like this, that withdraw, we will absolutely not write the body here because we don't know how this is going to be implemented. We have to declare that as abstract. So public abstract withdraw, if we declare it like this, it's going to complain because this class is not marked as abstract. When you have a class that has at least one method that has no body, it's marked as abstract, you have to declare the class as abstract as well. So at this point, everything works and it's fine. So along with this, let us create some tests. I don't want to do it from main, so I'm just going to create these things. How do you do it? Let me create a package called interface demo. And this is going to be another package, says bank account. And within that, let us create our test class. And this is for, say, bank account test. So we should have bank account test and savings account test and all of that like that. But I'll be a little bit lazy here. I'll try to avoid that. And I'll just write a test to say public test create account, right? And I need to import that annotation. So let's add that to our class path. Excuse me. No, not a dynamic test. Why do we get dynamic test? Yeah, that's better. So now that we have this test created, let's go ahead and create this bank account. So let's say bank account A equal to new bank account. We got a matching constructor, but we can't do that. Even if you know that there is a constructor that takes some ID, name, and balance, we can't instantiate this. No, we can't. Because what Java would say is that if you create an object and if you call the withdraw method on that object, what am I supposed to do? We don't know this, right? And for that reason, it's not going to allow us to create this object. It is okay. It is okay to do it like this, that you can declare that there will be a bank account called A, but you cannot instantiate that with bank account, because now if you call the withdraw method, there won't be any answer to that. What we can do then is we can call savings account, and now this thing works, right? So we can go ahead and say print this, say we're going to withdraw 10 taka from here, and print this again. So if you run this test, this guy Hassan has 500 taka initially in his bank account. So that should get printed. But when this person withdraws 10 taka out of the bank account, he will actually lose 15 taka, not just 10. I mean, who's asking you to work with Java version 5? What? Release version 14 not supported. Let me steal some code from here. What I want to steal from here is this plugin, Maven compiler plugin, where I have the source and target specified. So this is also something I didn't write. I had IntelliJ IDEA write it for me because I was using some advanced features in there, which I eventually deleted, but yeah, it was there. Why is release version 14 not supported? Didn't I change this a few minutes back? Kind of like feel stupid here. Yeah, finally something. So for some reason, it didn't remember the stuff that we did. And now it's back to somewhat normal, like it's giving us the expected output. So yeah, we got main and bank account, savings account, everything is working. But we aren't talking about interfaces yet. So what's the deal with it? See, when you talk about this bank account class, it's an abstract class. We have some methods and we have stuff in here that in some cases we're implementing, in some cases we aren't, and we leave it on the bank account subtype that we are creating, extending from a bank account. Okay. Now, what if I just want to look at the methods that would be supplied here? We don't want to worry about the implementation of it, but we just want to define these things. In such case, what we can do is we can create interfaces. Oh, I have to give it a name. Let's say we call this bank account operations. And the operations, this is an interface. I didn't choose class, I choose interface. This is where we will give names of the methods. So something like public void withdraw double amount. Okay. So yeah, there is nothing in it. And there is absolutely nothing in there. And we didn't have to mark them as abstract because by default, everything that you do in interface, they are all abstract. So what does it do, really? Like if you have something like this, why even bother? See, the advantage of doing this, let me leave the savings account like that, and let me create a new thing called current account. Okay. And this is where I'm not going to extend bank account because we have done this before. And you know that example. Instead of doing that, I'll just say implements bank account operations. That's the interface that we're talking about. And when we say that it's going to implement this, we will have to implement the methods. So all the abstract methods that are listed there, we will have to give implementation for each of them. Now, at the same time, since we haven't extended bank account, we are not getting the data members. We have to insert them here, private int ID, private string, what's that? Name, private double balance. All right. So that's what we have in current account. And let us also provide similar facilities. So something like have a constructor where we can pass the parameters, or the getters and a toString, I suppose. Okay, so now pretty much stuff are there, stuff that we need, but we don't have body for withdraw and deposit. I want to do it a little bit differently. For current account, the thing is that the bank knows that it's not going to give us any benefit, and we aren't getting any interest. So yeah, we'll pay something, I guess, for every withdrawal, maybe a lower rate. Balance is equal to balance minus amount minus 1 taka, because bank knows that for every transaction, it's getting something out of us, but it's not going to give us any benefit for deposit. So it stays like this. Now, what I'd like to test in here, we got a bank account test where test create, let me be very specific here, savings account. And I want to create something very similar. So let me steal my own code. But this one is going to be about current account, all right? And instead of creating bank account like this, what we will create here, we'll create current account. Okay. So pretty much the same setup. And if you run the test, you'll see the difference. So for test create current account, you see that we're losing less money. For the savings account, we are losing more money because it's just the way this is defined. For our bank account operations, when we write withdraw and deposit, withdraw is highlighted because it has some default implementation, deposit doesn't. Not default implementation, well, someone used it, that's why it's highlighted. So by nature of it, everything that you define within interface, they're all abstract, they don't have any body. It's up to you when you implement them, you write your own implementation. What an interface ensures is that you follow a certain design, that you have methods with some certain name. And that's actually quite crucial to know that someone's going to give that name. And I'll show you an example in a bit. Okay, so yeah, before we get there, this is before JDK8 that we knew interfaces, they won't have any body to any method. But things have changed, all right? Things have changed with JDK8, and later on, things have changed, and it keeps on changing with the interfaces. They're changing the rules of the game. So now what they allow, this public, by the way, it's not needed that you write it because by default they are public. You can have default methods. So when you mark something as default, you allow a default implementation within the interface. Now, this doesn't really make much sense here for deposit because we don't have any data member to play with. I don't have a balance field which I'm going to increase when we have some money coming in. So what I'm going to do here, just to show you that this actually works, I'll call this thing. So within our current account where we have the deposit method, we have the implementation of it, right? If we call this current accounts deposit method here, let's say I want to deposit 5 taka, a dot deposit 5 taka, and then we draw 10 taka. If we want to do that and we run it, you'll see that the printout, it doesn't appear. That someone called deposit, it doesn't show up. So for test create current account, you see that there is no such printout. However, for current account, if we choose not to provide this implementation, and we are allowed to do so because we have a default implementation, see, it doesn't crash, it doesn't complain. But if you comment this one out. We got compile error because we have a method that is abstract. It doesn't have a body, and no one gives this implementation. No one gives the body. So now if you run this example, you'll see that the code would still work. It probably wouldn't do the right thing, but it would still work. See? For the current account one, someone called deposit, this one gets printed, not for the savings account because there were no such thing. So to summarize, we create interfaces to name or to give names to the methods that have to exist if any class wants to implement this. And I gave you a very good example of data access object design pattern, that if you want to create database applications, there are some everyday tasks, everyday stuff that you'd have to allow on your data types that you create, like the CRUD operations, create, update, delete, and retrieve, all those things. You have to support those things. So if you create interfaces that have method bodies, no, not method bodies, method names specifically related to each of these things, then when you implement those interfaces, you will be forced to write the implementation for each of them. So there is no chance that you can miss out on those things. At least you'd have to provide some dummy body, which you'll have to come back to and make sure that you have implemented that. So that's the benefit of having an interface that people know. Whoever uses your program, uses your library or API, they will know that there are some such methods that they can call and everything will be done. So abstraction is the benefit that you get out of having interfaces. So that's one thing. All right. So the next thing I want to show you, it's a different example. And that's why I want to create a different package. Okay, I wanted to show you a sorting demo, or maybe keeping in line with the bank account thing. Let me rename this. So I created a bank account package, and I'm going to create a student package where this is going to be a little bit confusing, but I'll create a class called student. For every student class, we'll have private long ID, private string name. All right, so we have this. Now, what I wanted to show you that for a student type, if we create another package, student. And so we are going to create a student package where we're going to put in some test code. I'll just call it student test. Okay. By the way, I forgot to flesh this out to write the methods that we will absolutely need. So we need a constructor with these two things. So we need some getters. We need a toString at least. Okay. So what I wanted to show you in the student test is, let's say we have a method public void test create student. Right? So that we know at least that we are able to create students, like student A equals a new student. So that's a student. So let's say we have another student ID 11. Right, so we got 3 students in here, and if we manage to create them properly, we should be able to print them out, right? So A, B, and C. And let us create this test with a test annotation, and we can run the test. Okay, sorry about that. I had to respond to Sharia, sir. So yeah, we wrote this test, and it's actually working, right? What if we want to create an array list with all these 3 students? What if we want to sort them in some certain way? Now, just to give you an example, okay, I want to show you how you can sort an array of strings, or you can actually sort a list of strings as well. So let me show you both the examples. Let's say we have an array of strings, and let me just call it strings, and I'll create a fixed array. So just the same example, Hassan, Rahman, and Ahmed. So if we were to sort them, Ahmed should come first, then comes Hassan, and then after that comes Rahman. So in Java, this is really very simple. You just say arrays dot sort strings. And to print them out, you can run a loop to print them out, or you can use something called arrays.toString. So let me show you what you know already for string s in strings. Print out that string. So let's try that first. Okay, so test string sorting. So yeah, it actually works. So we got these 3 things coming out in that fashion. And what I was saying is that if you don't want to use a for loop to print, you can do this arrays.toString and pass the name of the array. And then it will print the whole thing in a line as a list. So let me show you that output as well. See? So this can be quite convenient in some certain scenarios. So whichever way you prefer, you can print them out. It's not a big deal. So that's that. And to show you the other example, if we want to create a list, like list of string, and let me give it a different name. Let's call it names equal to new array list. And within that array list, we can add names dot add, just in the same way. So we got Hassan, Rahman, and Ahmed, right? So if you want to print this list just like this, you can say system out println names. And let me show you that it prints out the unsorted version because we didn't sort it yet. See, this is the array listing. Now, in order to sort this, instead of calling arrays.sort, this is just a different thing that we have to use. It's called collections. So collections dot sort names. And this actually works, right? So whether you're using an array or you're using a list, in both cases, you can easily sort strings, no problem whatsoever. So Java can sort strings, Java can sort numbers, and all these things, the predefined data types. Um, yeah, Java knows how to sort them. So what if we have all these students, right? What if we want to sort these students? Can Java do that? Let us create a new test method. Okay, so this is where I want to create the students, like so, and I want to create a list of students. And within that, I want to add each of those things. So students dot add A, B, and C. We can print them, of course. No problem with printing. Okay. But there is no sorting here. You can say that they're probably sorted by ID, but let me try something different. Yeah. So for example, if I have the first one, A has ID 20, B has ID 11, and C has ID 32, in such cases, you'd see that they're not sorted by ID, they're not sorted by name, none of this. So what if I want to sort by ID? Or what if I want to sort by name? Have we told Java that this is what we want? We didn't. So if you call now, if you call collections dot sort students to have them sorted, it just wouldn't work. No, because Java doesn't know how you can sort to students. Java knows how you can sort to strings because Java knows how you can compare and measure if one string is heavier than the other one. Okay. However, for students, we don't know any such thing. And the answer to that, how you tell Java that two students are comparable, is if you implement an interface called comparable, which allows you to compare one student to another. And we got to implement this method. This is a compare to method, which takes another student. And let me give it a different name. Let me call it that. And you'll see the reason why I call it that way. So now there is no more complaint. And if we run this, we won't get the proper output, but we will get some sort of output anyways. All right, so it doesn't sort anything, but we do get something out of this. Now, what I want you guys to understand is how this comparable this interface works. So what it does, it gives us a method something like this. This method takes an object of type T. Now, what's this T? This T can be anything. It can be a student, it can be a string, it can be whatever you want to create. It can be a bank account even. So it returns a number. So the way it works is if you imagine that you got a scale and you want to compare two things. So we may put more weight in here compared to less weight here. So in that way, this thing will go down and this will go up. So that's the comparison in real life scenario. Now, think about another scenario in a programming sense. Let's say we got two variables and I'm designing cups for them to hold the values. Let's say we got A and B, right? If we put value 10 in here and 7 in here, if we do a calculation like result equal to A minus B, then what do we get? For this particular scenario, for A equal to 7, actually A equal to 10 and B equal to 7. Let me pull this off here. And I'll make other examples further down here. So in this case, where we have A minus B and A is 10 and B is 7, this gives us 3, which is a positive value. And this actually tells that A is greater than B. So when we do A minus B and we get a positive value, it tells you that A is greater than B. Whereas, if you take a different example, let's say we have 12 in here for B and 10 for A. If you do the same subtraction, a similar subtraction, you get negative number. Okay, so that tells you, if you do A minus B and you get a negative number, that tells you that A is less than B. And finally, if you take this example that A is 10 and B is 10, if you do this, you'd get 0. And that tells you A is equal to B. Is that clear? What I mean to say is that this integer thing, if this is positive, that would mean that the first thing that you have is greater than the second thing you got in your hand. If the result returned here is negative, then perhaps, not perhaps, for sure, the first thing is less than the second thing. If the return value is 0, then you know that these two things, they're equal. So where are we headed with this? And where is this B? This T thing that I wrote in here, this is actually the B. And then you'd ask, where is this A then? Well, that's the thing that we got to answer. So when we have something comparable, let's say a student is now comparable. Okay, let's say we have a student S1, and we'd have another student S2. What we are allowed to do now is to write S1 dot compare to. S2. So that right away separates these two things out. Okay, I'm using two different colors to say this. So this S1, it is this. And this other thing, this is what we call B. And to make sure that we see this clearly, I'm using a different name called that, so that we have a clear distinction when we are talking about this versus that. Okay. So if you get this idea, what you can then imagine is that if we want to compare the ID of a student with the ID of another student, we could just say that this dot ID minus that dot ID. And that would give us a positive value or a negative value or 0, and that we can easily compare. So if you get that idea, within compare to, what we can do, we can write int result equal to this dot ID minus that dot ID. However, these two things, the ID values that we are getting, they are of long type, but what we are returning is integer. So we have to convert that into integer, otherwise we'd get a compile error. And now we can return the result. So in doing all of that, sort students. See, previously we had 20, 11, and 32. Now we got 11, 20, and 32. And interestingly, if you want to do descending order sorting, you can easily do so by reversing the signs. So 32 should come first, then comes 20, and then comes 11. See? So it's quite easy. Now, what's the takeaway? The takeaway is that we have a library method, sort. We have that for arrays, we have that for collections. And it's a really nice thing to have a method such as that, because now we don't have to write the implementation of any sorting algorithm. We can just call the sort method and be done with it. So what's the catch in here? The catch is somehow we got to be able to tell Java that you can compare two students. We can measure which one is lighter and which one's heavier. Okay, we have to teach Java how to do it. And this is where Java doesn't know and Java cannot know, because these are classes that we are creating now. So what Java allows, or Java developers, they design this thing in such a way that they have created interface called comparable. And in this interface, we can now tell exactly how two students can be compared. So this is the real benefit of having an interface, that you don't know exactly how people are going to implement this. Java developers never knew that there will be something like this, something like a student class. But they knew that if someone defines how comparable works, then we can actually compare two elements. And if we can compare two elements, we can compare 100 elements. And in doing so, we can sort them all in one place. So this is exactly what we are attempting. We are learning how to design interfaces. And that's the real benefit, that you don't have to answer this right now. You don't have to know how to do a certain thing, but you have to know that this thing can be done. So Java developers knew that comparable can be called on anything that people want to sort. But in order to do it, someone who is defining these classes, they should be able to tell how to compare these things. Okay? So that's pretty much it for today's class. I want to stop right here. I want you guys to go through this example and learn how interfaces can be used. And based on this knowledge, we can move on with JDK 8 features that were brought in, like functional programming. I'll get to that. But before we get there, we'll talk about exception handling. That's the other thing that I didn't talk about yet. Okay, so that's it for now. Thank you guys for those of you who are watching these videos and trying this out. Stay safe. Bye.